Sí.
Sí, bueno. Bueno, buenas tardes desde Holanda para todos. Yo tengo que cambiar el eco. ¿Me puedes escuchar bien? Do you hear me well, yeah?
Yes, Dr. Rossiter, we can hear you pretty
Okay.
well.
Okay. Good afternoon, everyone, or good morning. I'm presenting on behalf of my co-authors, Stefan Montel and Luis de Sousa, and we're from Maastricht in the Netherlands. We're going to talk about accuracy assessment of WRB products, especially in the context of soil grids. And our basic point is that, of course, when we make a map, we don't have the class always correct. I mean, that's clear. So we want to report that, of course, and we use a cross-correlation matrix, or what they call a confusion matrix, and we get the users or producers accuracy, which Dick Bruce calls, I think, very nicely, the map unit purity from the user's point of view, or the class representation from the producer's point of view. So this is a standard thing we do. A little bit about soil grids, just so you know. This is what the product we're talking about. You can go look at it. This is our latest paper. And what we do in this, we have decided to only predict reference soil groups of WRB 2006. A previous version, we tried to look at the various one qualifiers, but there were lots of problems. We only had 27,000 profiles. Definitions changed. They were used in a lot of different systems. So we hope to pick this up again. But anyway, for now, we at least try to get reference soil groups. But what I'm talking about now will really apply to any soil class map. This is just a picture of World Reference Space. I hope you, of soil grids as you might know it. Here's a location in Mexico. We predict a calcisol, and you can go look at this and see all about why we do that. These are the profiles we're using, but most of these are not classified. Most of these are being used for soil properties, but we don't have a correct classification, and many don't even have a classification. So again, you can look at these profiles. They're from our WOSIS database, but the point is we don't really have a lot of background to map the classes yet. So how do we evaluate the mapping accuracy? What we do is we have this cross-correlation matrix, which is based on cross-validation. So what we do is we have a random classification forest with the known points. And then we compare the predictions with the known points. And the reason I call this cross-validation is that we use out-of-bag points. So we only use in the random forest. The very nice thing about it is in every tree, there are points that are not used. And so when you only use those, you get a fairly good cross-validation. It's not exactly the same as data splitting, but the same idea. So what we call the naive accuracy is just the sum of agreements on the diagonal divided by the total number of predictions. So that's how accurate the map is in a very naive sense. And of course, we can compute the per map class purity. This is exactly what you would do with a land cover classification or, for example, in remote sensings. The only difference here is we do use a cross-validation approach, which we think is statistically sounder than using the predictions. But this is misleading. And some years ago with my colleague Zhang Ganling, who a lot of you know, in Nanjing, and my colleague Zheng Zhong, we wrote a paper on accounting for taxonomic distance. And you can go read the paper, which is much more complete than what we're trying to do with soil grids. And the concept here is not all errors are equally serious. And I'll show some examples in a minute. So for example, the reference soil groups might in some cases be functionally close or somewhat close and far from others, so that an error you make might not be so bad as it seems. So you have this idea of a partial credit matrix that makes it so that your map is a better evaluation of how well this is for the user. So it's not, if you just have the naive measure, if you're off by an inch, you're off by a mile, as you might say. In this case, we're going to try to allow some partial credit for answers that are not completely right, which is exactly what you had in high school when you did your math tests and you got part of the question right. Sometimes the teacher would give you a partial credit. Now, there's some similar work here that is not exactly the same, but I leave this for you to look at. Some similar thinking about how some groups are closer to others, although no one has really done it for accuracy assessment. So the idea of the partial credit matrix is we make a matrix with the same structure as the cross classification matrix, but the off diagonals now have some partial credit. They could be from 0, so no partial credit for an error, and 1 for no penalty to the error, meaning that it doesn't really matter that we made that error at all. We then use this in the accuracy assessment so that the reported accuracy better reflects the usability. So in my earlier article in the paper, there were 4 ways to assign the credit: expert opinion, a numerical taxonomy approach, distance in the taxonomic hierarchy, that is how far you have to navigate through the hierarchy to get there, and an error loss function, which has to do with what would happen if you would use the soil the way it was mapped as one soil, but it's really another. So there are lots of ways to look at this, and you can look at this as the user or the producer, and of course, I'm more interested in the user. The way this works is in the overall accuracy, you have an additional factor here, which is this weight. And this weight is what you might give to an off diagonal. And if this is not 0, then with that proportion there that is the error, that you will give it a little bit of a credit, and the same thing for the map unit purity, which is just down the column. And the point to see here is that you have these weights that you can put in. If you take this away, you just have the naive way you would do with a confusion matrix. So in soil grids, we decided that since we're only predicting the reference soil groups, we make a 32 by 32 weights matrix, which is each reference group as actual and each reference group as predicted by the mapping method. And we would like to use the expert opinion method. So we've sent out a bit of a questionnaire, but this is our idea. And the idea is the experts, which are you all, are asked to consider what we're going to call the holistic similarity between the mapped class and the actual class from the user's point of view. And this is the key question. You know, if the user would take your map and it gives a certain classification, and they would use it according to the recommendations for that classification, but it's really another class, how bad would that be? And this, of course, is somewhat context sensitive, but the concept is you should have some idea of what's closer or further. And what we're going to do in our next version of soil grids, we'd like to report the accuracy, both our naive accuracy and also the weighted ones. And I'll give an example. This is an example actually from the paper, the earlier paper. Suppose we have a deep soil, which is mainly coarse fragments. Actually, we heard about this in a previous talk. We were talking about the leptosols in the horizon designation. So we have a sandy loam with a cambic horizon, but it's mainly of coarse fragments. And besides the coarse fragments, we identify a cambic horizon. Well, if we have 20% by less by volume of fine earth, then it's going to be a leptosol, which would be cambic skeletic. If this is not met, it's going to be a cambisol because we'll have a cambic horizon. It will be considered a skeletic cambisol. So you see the soil being very similar, also very similar in its use, and it can end up in 2 reference soil groups. And I'm sure you can all think of examples like this. Similar soils and their properties and use potential. Another point here is that estimating volumes of coarse fragments is not precise, although this previous talk on the estimation from photographs was an interesting idea. General, to say, is it really 20% or 15 or 25 is pretty difficult. So we might, in this case, give a partial credit of 90%, let's say. But if we now have to work at the RSG level, this is not going to be good because we don't know that the cambisol is skeletic. We don't know the leptosol is cambic. So in this case, we are comparing all the cambisols to all the leptosols. And here we're going to have to give a lower credit. If I predict a cambisol and it's actually a leptosol, maybe I give a credit of 0. I say, no, a general cambisol and leptosol, maybe in the other direction, I give a small partial credit because that has higher use potential. But you can argue about these, but this is the concept that you think, well, how close are these? And in the case of the reference soil groups, with a really big group like the cambisols with so many types of soils in there, just having a cambic horizon, you might not find much that's similar. So how do we fill the matrix? Diagonals 1, off diagonals 0, and we fill in the off diagonals if there's partial credit. I'm giving a small example of just a hypothetical. This is just from my brain here. Partial credit made for RSG. And let's look at the red one here. So for example, ferrosols and plintosols. I might say if you map a plintosol and it's really a ferrosol, I'll give it a 0.8. Now, my Brazilian colleagues might really disagree. That's fine. We'd like to hear that. If we look, for example, at podsols and andesols, well, they have a certain similarity in the mineralogy, so we might give that a 0.25. Solenchoks and solonets, maybe 0.5. So this is just the idea of how we might fill this in. And then you see something like plintosols and solonets. Obviously, we give this a 0. You map a plintosol, it's really a solonets. The use is utterly different. So our concept is to get the community to fill this in, and then we would be able to have maybe a more realistic, from the point of user, explaining. So here's just a few examples. Similar reference soil groups, chernozems, phaeozems, and castenozems are obviously similar, and you could decide to what degree. Stagnosols or glayosols are both very water influenced, although it comes from 2 different ways. The use is definitely different, but maybe not too. Dissimilar, well, there are just some examples here that are obvious. Many examples of highly dissimilar. And then you might get some partially similar ones that if we would go to the lower classification levels, which we're not doing right now, but if we would go to a more detailed, if you made a map, for example, in a smaller area with a number of groups with qualifiers, you might do this. If you have technosols, but you have technic qualifiers of other reference soil groups, there's obviously a similarity there. Vertisols, vertic qualifiers, the same idea. So if you were at a lower level and it wasn't a vertisol but had a vertic qualifier, you might, if it were incorrectly mapped, you might give it a partial credit. Lower levels, we do not have enough data for this in soil grids. And if we use the first qualifier, even with that, the matrix would be huge. 300 by 300, I don't know, 600 by 600. So probably in that case, instead of using the matrix directly, you would use some kind of rules. We have an idea that instead of mapping the lower levels of the world reference space, we might just map diagnostic properties of horizons. We think that might be easier, and not to go to the full classification, but say, okay, do we have enough information to say we have a feralic horizon, for example, or some diagnostic properties. Whoops. And then we would evaluate the accuracy by expert opinion of similar properties or horizons. So if we got to that level, we would be looking at this kind of stuff, and we'd be asking for a partial credit if you say it's Chernik, but it's really, if we map it as Chernik, but it's really Malik, would you give me some credit? That would be the idea. So the conclusion here, is this a reasonable approach? Can the community contribute to the expert opinion? Should we have a circular letter? Should we send out a website? Maybe just in general, do you like this idea of giving partial credit for mapping errors that, from the user's point of view, are not so serious? Thank you.
Edward.
Hello, David. I had a comment about your conclusion slide. Thank you for your presentation, by the way. The last possible question you had is, should we send out a matrix to be commented on or filled in by experts? It would be a very helpful idea. You could gather opinion from a wide audience, and I think it would be very helpful for developing models and conceptual relationships between these soils.
Thanks. That's exactly our idea. And we would then be able to see if there were a consensus in the community, and we have, this Congress and the World Reference-Based Working Group and interested people. If we found a consensus, then we could just publish that maybe as a group effort, and then we would be able to use that and have some justification for it.
Dr. Curtis.
So do you plan to do something similar with soil taxonomy? And just to elaborate on that, so for example, there can be an entisol right next, a Tory orthent, Riddick moisturizing Tory orthent right next to a haplocambid, and it makes an ibridisol only with like 4% increase in clay. So there you've got different orders, but they function very similarly. But if you go down to the family level, like Corysolomi mixed thermic Tory orthent and Corysolomi mixed thermic haplocambid, I think there's a lot more similarity. So my family level.
Right. First off, we don't deal with soil taxonomy at ISRIC. This is the world reference base, and we use world systems. We recognize that we have a lot of profiles that are classified in that, and we don't deal with the families and series at the level of detail that the NRCS does. So what I would suggest there is, of course, you could do that yourself, but I think what's really interesting would be the mapping legend in a given county or MLRA or whatever that you yourself, especially with the series, you could easily do with the series. And that's what we did. I used some examples of that in my earlier paper. I used some series from North Carolina where I mapped in my youth, and I'm quite clear on the level of similarity. In fact, there we used the site index as an example. We used the site index for the loblolly pine and use that as the error loss function. You could also do it from an expert opinion point of view. And the point exactly there would be if the landowner or the land user uses it wrong, you map it wrong, but they use it that way, how bad off are you? So I would encourage you to do that at the lower levels, at that local level where the lower levels are meant to be used.
Thank you.
Dr. Peterson.
Yeah, hello David. You told us that many profiles you have are without classification. Yes, but there are some with classification. How can you make sure that this classification is made long time ago? And how can you make sure that this is a correct classification according to the system you want to use?
That's a very good point, and that's one of the main problems we have. We ideally would like to reclassify. I mean, if we have enough information, now it would be a big job, but sometimes if you look at the original profile description we have in WOSIS, we actually don't have all the information to reclassify it exactly. We could make an effort at it. Now, this, I think, where the partial credit comes in a little bit, because if it were a misclassification or even if the classification has changed, we would hope that wouldn't have changed it hasn't changed the soil. It hasn't changed that soil use. So we would hope the classification change would be reflected in a higher partial credit, even if you used an incorrect classification for it. But that's a very serious problem. I've always thought that one thing we should do is when we classify soils, that when we come to a decision that we have to make, like less than 20% coarse fragments, that we kind of can split that and give a probability of each one and end up with several classifications of the same profile. You might not like that, but and we would hope that those several classifications, based on our uncertainty about one of the things we're looking at, or if we're very close to the line, they would end up not having a big effect on our map. But what we're trying to, let me just say what we're trying to do now in soil grids specifically is when we do present this, we would like to give some realistic idea of how good the map is. So there are other ways to do it, because we can do in the random forest, we can also do the probability of each group, and then do some and then there's another way that I've developed to look at the mapping accuracy based on those probabilities, but that's another talk.
Thank you very much. This is our last intervention, so we need to.
No hay más nada.
Now, our last speaker of this conference is Rossiter. I don't know if I.
Because okay. Because we have German roots, but my mother language is Portuguese, so it's also for me pronounce my last name very correctly.